Imagine sending a letter and eagerly awaiting a reply. In the digital world, that's exactly what happens every time you interact with a website or an application. You send a request, and then, after a journey through various systems, a response comes back. The life cycle of an HTTP response describes this entire journey, beginning from the moment a server starts processing a client's request until the complete response is successfully delivered back to that client. This process is a carefully orchestrated sequence governed by the Hypertext Transfer Protocol. First, after receiving a request, the server's application logic determines what information is needed. It might retrieve data from a database, perform calculations, or access other services. Once the necessary data is gathered, the server constructs the response. This construction involves setting a numerical status code, like 200 for success or for 100 and for 4 not found, which immediately tells the client the outcome of its request. It also includes adding various HTTP headers, which are like metadata for the response, specifying things such as the content type, caching instructions, or cookie information. Finally, the actual data, often in the form of HTML, JSON, or images, is placed into the response body. Understanding these components is crucial because each one plays a vital role. The status code isn't just a number. It's a critical signal guiding how the client should react, whether to display content, show an error, or try again. Headers, such as content type, inform the client how to properly interpret the response body, for example, as an image or as plain text. The cache control header dictates if and for how long the client, or any intermediary proxies, can store a copy of the response, significantly impacting performance by avoiding redundant requests. This structured approach ensures that web communication is both efficient and reliable. For developers, understanding this lifecycle means crafting responses that are not only correct but also optimized and easy to interpret. It involves selecting the appropriate status code for every possible outcome of a request and populating headers with relevant information to enable proper caching or manage session states effectively. Consistent response structures, especially for API endpoints, help clients predictably process the received data, making integration smoother and debugging less complex. By analyzing response headers and status codes, one can quickly diagnose issues, whether it's a client-side problem or a server-side error. A subtle but important detail in this lifecycle is the role of network protocols at lower levels. Once the HTTP response is fully formed by the server, it's passed down to the transport layer, typically TCP, for actual transmission across the network. TCP then breaks the response into packets, ensures their ordered delivery, and reassembles them at the client's end. The server might also send a connection, keep alive header, indicating it intends to keep the underlying TCP connection open for subsequent requests, reducing the overhead of establishing new connections and improving the round-trip time for future interactions. This keep alive mechanism is a clever optimization for performance. Ultimately, mastering the lifecycle of an HTTP response is more than just knowing a sequence of steps. It's about gaining a deep insight into the fundamental building blocks of web communication. This knowledge empowers you to design more robust web applications, optimize their performance, and effectively troubleshoot issues from the server's perspective, ensuring a seamless and reliable experience for every user.
If this helps you code smarter, like, subscribe, and stay tuned for more.